condense logarithmic expressions, we can use the product, quotient, and power rule in reverse. While we typically view them as expanding, we can view these as condensing. So for m greater than 0 and n greater than 0, log base b of m plus log base b of n is equal to log base b of the quantity m multiplied by n. For our quotient rule, we have log base b of m minus log base b of n is equal to log base b of m divided by n as a quantity. And for our power rule, we have p log base b of m equals log base b of m to the p. So instead of viewing it as exponents being brought down as coefficients, we're taking coefficients and making them exponents. We're taking differences of logarithms and making it a quotient. And we're taking sums of logarithms, again with the same bases, as a product. So let's look at a few examples. Express as a single logarithm, and if possible, simplify. Well, first example we have is log of 1,000 minus log of 100. Because this is a difference of two logarithms, we can make this a quotient. So log of, and our base here is 10. It's understood as a common log. So log of 1,000 divided by 100. 1,000 divided by 100 is 10. And because this is a common log, log base 10 of 10 would be equal to 1. Second question, we have 1/4 log base b of x plus 4 log base b of y minus 2 log base b of x. Now when we're condensing, we want to begin with the power rule and then sort of work backwards. So 1/4 log base b of x would be written as log base b of x to the 1/4, which is the fourth root. All right, now the 4 log base b of y would be written as plus log base b of y to the 4th power minus log base b of x squared from our coefficient of 2. Now we can move on to our product rule and write log base b of x to the 1/4 plus log base b of y to the 4th to the 1/4 and to the 4th power. Respectively, we can write those as log base b and write that as the product. So that would be x to the 1/4, y to the positive 4th minus log base b of x squared. Now, because we have subtraction now between two terms, this will become a quotient because of our quotient rule. So this will be log base b of x to the 1/4 power, y to the 4th, divided by x squared. So in our numerator, we have x to the 1/4 and y to the 4th. And in our denominator, we have x squared. There's one more thing we can simplify, and that is x to the 1/4 divided by x squared. We can subtract those exponents, and 1/4 minus 2 is negative 7/4. So that this would simplify completely as log base b of y to the 4th power divided by x to the positive 7/4. Next, express as a single logarithm and if possible simplify. Log of 25 plus log of 4. Based on our product rule, we could write this as log of 25 times 4, which would be log of 100. Because this is a common log with a base of 10 and 10 to the 2nd power equals 100, this would equal 2. Our next example, we have natural log of 7x plus 6 minus natural log of x. Well, this is subtraction between two logarithms, so we can write this as a quotient. Natural log of quantity, and we have a numerator, 7x plus 6, and a denominator of x. We're dividing. And because that expression doesn't factor, that is our final answer. Now for our last example on this slide, we have 2 natural log of x plus natural log of quantity x minus 2. Again, we want to go to our power rule first, so this would be natural log of x squared plus natural log of x minus 2. Now, because we have a sum of 2 logarithms, we can write this as natural log of the product of x squared and the quantity x minus 2. I'm going to put that in parentheses twice to be very clear about what I mean, what my argument is. Now for our last example in this objective, express as a single logarithm and if possible simplify. Log of the quantity x squared minus 25 minus log of x minus 5 as a quantity. So this is subtraction between 2 logarithms, so this will become a quotient. So log the natural base of 10 of the quantity x squared minus 25. Let me say that again. My common log, so I have a base 10. So my numerator is x squared minus 25. My denominator is x minus 5 inside, or as an argument to my log. Now, we cannot cancel anything at the moment, but if we factor this, if we write this as log of quantity, and my numerator will be x plus 5 multiplied by x minus 5, and all that's divided by my denominator of x minus 5. If I write it in that way, then the x minus 5 factor and the x minus 5 as my denominator can form a 1. So this would be equal to log of x plus 5. And since we don't know what x is, we can't evaluate that.